Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today in this topic, I would like to explain what is lens and how many types are there. It's nothing but simply I will be given a simple explanation or a brief idea about lenses and its types in this part video from the chapter of refraction of light at curved or spherical surfaces. In our previous video, in the same chapter, we clearly discussing that what is the spherical or curved surface and what are the important terms involved in it and what is the gaseous relation for a single refracting surface for finding the where the image will be formed based on that one. Then finally we can prove N2 upon V minus N1 upon U is equals to N2 minus N1 upon R. That is the final formula we can get from that one. And also we are discussing what are the rules for sign conversion. These rules for sign conversion are important for the 2 marks. What are the rules for sign conversion? Once again you remember. Pole of the curved surface. Further in the lens we discuss as the optic center. Okay. So pole of the curved or spherical surface we consider as a origin. All distances must be measured from pole of the curved surface only. Distances measured in the direction of incident ray we taken as positive. The distances measured from the pole opposite to the incident ray we taken as negative. Height measured above the principal axis we taken as positive. Height measured below the principal axis we take as negative. These are the main rules for sign conversion. That's why in the light chapter mostly we follow these rules for sign conversion. Mainly these conversions are useful for us in the curved or spherical surfaces. Okay, what is our topic? Okay, today our topic is lens. What is the lens? How many types are there? Lens is a transparent material bounded by two refracting surfaces. So, lens is a transparent material bounded by two refracting surfaces of which one or both spherical surface. Listen very carefully. Refracting surface means two types are there. One is plain refracting surface, another one is the spherical surface. That's why when the light will be travel from air to water, the surface of the water is a flat, is nothing but it is the plain refracting surface. But when the light is fall onto the lenses, either convex or concave lenses, are nothing but on the spherical surfaces. When the light will be fall on the spherical or curved surfaces, then okay, that refracting surface is called curved refracting surface. That's why. So what we can say is that lens is a transparent material and bounded by two refracting surfaces, of which one or both spherical surfaces is nothing but okay, lens is nothing but it must be having two refracting surfaces. It is a transparent material. Generally lenses are made up of glass or plastic. So it is a transparent material. We know that bounded by the two refracting surfaces. Among the two refracting surfaces, at least one is must be a spherical or curved surface. That is the okay lens. Once again listen, lens is generally made up of glass or plastic. Lens is a transparent material bounded by two refracting surfaces, of which one or both okay, spherical surfaces is nothing but at least one is must be a spherical or curved surface in where in the lenses. So now, what are the types of lenses we discuss in this time? I says that lenses are made up of which one? Either glass or plastic. Mostly we are using the glass and rarely we are using the plastic also. We are using the spectacles. Okay, some of the spectacles are made up of glass and okay, the roadside one is available. What is that one? They are the plastic. That's why lenses are okay. The spectacles is also one type of lens. The lenses are made either glass or plastic. How many types of lenses are there? Means two types of lenses are there. One is convex lens, or it is called convergent lens. Second one, concave lens, or divergent lens. So lenses are mainly classified into the two types. One is convex lens or convergent lens, and second one is concave lens or divergent lens. Now we discuss in this time which type of lenses we are called convex, while the other is called concave. And also we discussed so why convex lens is acts as a converging lens and concave lens is acts as a diverging lens. First one is convex lens. Which type of lens we are called convex lens? Lens means I clearly explained. Lens is a transparent material bounded by two refracting surface, by which one or both are spherical surface. Is nothing but at least one is must be a spherical surface. But further they are classified into the two types, convex and concave. Which type of lenses we are called convex? First we discuss about this one. Thinner at marginal or edges and thicker at middle or central part. That lens we are called which lens? Convex lens. Listen very carefully. A lens, okay. A lens have thinner at marginal and thicker at the middle. That type of lenses we are called convex lens. convex lens acts as a convergent lens. Convex lens acts as a convergent lens. So listen very carefully. A lens have thinner at marginal and thicker at middle. That lenses were called convex lens. Convex lens acts as a convergent lens. Now we discuss that. Okay, convex lens further classified into the mainly 4 types. What are that one also we discussed. Types of convex lens. Okay. So here, after this one only, I explain that why convex lens acts as a converging lens. At a time I will explain convex lens acts as a converging and concave lens acts as a diverging lens. So types of which one? Convex lenses. So the convex lenses are further classified into the 4 types. 4 types of convex lenses are available. First one is equi-convex lens. First one. Next, second one. Biconvex lens. Third one. Plano-convex . Next, fourth one. Convexo-concave. Convexo-concave lens. So here, this is the convex, this is the concave surface. So the how many types of convex lenses are there? Mainly 4 types of convex lenses are available. Equi-convex lens. Equi-convex lens means, so here you are observing that from this one, first I say that very clear. Generally it is a small. Okay. So we are observing that these 3. This is the called hedges or marginal. A lens, okay, which has thinner at the edges and thicker at the middle. So here at the middle you are observing that it is the thicker, means more width is there. At the edges are marginal, it is the thin, means small is there. That's why this type of lens we are called which lens? Convex lens. Listen very carefully. A lens which has thicker at the middle and thinner at the edges. That lenses we are called convex lens. Convex lens acts as which type of lens? Convergent lens. That is I will explain later. And how many convex lenses are available to us means, so 4 types of lenses are available. Equi-convex lens. Equi-convex means this spherical surface radius, this spherical surface radius both are equal. Means this focus point, this focus point both are equal. Next, biconvex lens. Biconvex means this is the convex, it is also convex, but these focus are not same. That is the meaning. It is nothing but this radius and this radius of the curvature is both are not same. But here both are same. That is the meaning. Next, plano-convex. Plano convex means one surface is plane and another one is the convex. Okay, next convex or concave. Okay, so this surface means the reflecting surface is outward, that is the convex, we know that. The reflecting surface is inward, that is called concave. That's why the reflecting surface is outward, this is the convex, and the reflecting surface is inward, this is the concave. That's why convex and concave both are combined here. That's why it is called convex or concave. So it is the equiconvex lens is nothing but both are having the same radius of curvature. It is the biconvex lens. Both are spherical surfaces, but they are not having the equal radius of curvature. Plano-convex lens, one is the plane, another one is the spherical surface. Next here, convexo, concave. These four types of lenses are available to us. Next one is concave lens. A lens which is thinner at middle and thicker at marginal or edges. So listen, a lens which is thinner at middle and thicker at marginal or edges is nothing but central part is small or thinner and edges is thicker. That lens is called concave lens. So simple difference. Convex is nothing but middle is thicker and edges are thinner. But concave means middle is thinner and edges are thicker, just opposite. But the lenses either convex or concave, so this lens's refractive index is must be greater than the refractive index of the surrounding air. So generally we know I said that lenses are made up of the glass. What is the refractive index of the glass? 1.5. What is the surrounding air? We know that surrounding medium means air is the surrounding medium. Surrounding air is, we know that its refractive index is 1. That's why, so the glass refractive index is more than that one. But anyway, the refractive index of the lens is must be greater than the refractive index of the surrounding medium. At the time, the convex lens, which is thinner at the edges and thicker at the middle, are called convex. The lenses which is thinner at the middle and thicker at the edges are called concave. Next one is and one more thing. Concave lens is acts as which type of one? That is also correct. Concave lens acts as a divergent lens. So that is very important. Concave lens acts as a divergent lens. I said clearly, I will explain in this video only. Types of concave lens. How many concave lenses are available means like same 4. First one, equiconcave lens. Second one is biconcave Third one, plano concave. Fourth one, concavo convex. Concavo convex. Sorry. Concavo convex. This one. So here, listen. Equiconcave means this side, both radius of curvature is same. Biconcave, okay, both radius of curvatures are not same. Plano-concave, one refracting surface is plane, another one is must be a concave. Here, concavo-convex. This is the concave, it is the convex. That's why these four types of concave lenses are available. Now we are discussing. Okay, does really the convex lens is acts as a converging lens, and while concave lens is acts as a divergent lens. First we discussing about convex lens acts as a converging lens. This is the one. Convex lens is acts as a converging lens. First, we can take the equiconvex lens mainly. That's one. This is one equiconvex lens. This is the optic center. This is the principal axis on the curved surface. Okay. So later I will explain that how many center of curvatures are there, how many focal lengths are there. In the next video, I clearly explain about that one. Okay. Optic center. So here, incident rays. These are the incident rays. Okay. So the incident rays are coming from the distant object. That's why if we know that light is always travel from one place to another place in a rectilinear propagation. It's nothing but straight line path only. If the rays are coming from the distant position of the object, we are always consider the rays are parallel to the principal axis. These two are, we can say as the incident rays. These two rays are coming from the infinity position of the distant position of the object. But these two rays are parallel to which one? This is called, we know that already, principal axis. That's why the incident rays are parallel to the principal axis. Now here, equiconvex lens will be having how many refracting surfaces? Two. Okay, it is the first refracting surface and this is the second refracting surface. That's why it is the first one, it is the second one. Now the rays are coming from the object. This side is object is there. It will first fall onto the which one? First refracting surface. That's why in this time the light rays are behaves to travel from rarer medium to denser, because of it is the rarer medium, it is the denser medium. Again this is rarer medium. Is it correct or not? Rarer medium up to here, this is the denser, it is the rarer, because of it is made up of the glass. So at this point, I said very clearly the refraction at the curved or spherical surface in the previous video. So generally, okay, during the when the light will be formed at the any curved or spherical surfaces, okay, for drawing the refracted ray, for showing the refracted ray, you must be draw a normal. But to draw the normal, what you are considering here? So we draw a tangential line at the point of incident. The tangential line is represented refracting surface of the part at that point of incident. That's why at this point, okay, for this one, we draw an tangential line. Here, this part, we can say that. So this is the refracted ray. That's why for the refracted ray, we draw a normal. Correct or not? That's why we know that when the light is travel from rarer medium to denser medium, it will be bent towards the normal. That's why it is the normal. That's why slightly bend and travel and fall onto the which one? Second refracting surface. For the second refracting surface, this one, okay, it is the A, B, C, it is the D, okay, or here it is the B, we can say that it is the C, it is the D. So A, C, B is the first refracting surface. For this one, the light ray behaves to travel from rarer to denser. That's why after the refraction, it bends towards the normal, like this one. We know that. Next, again, the light will travel inside the lens and fall onto the second refracting surface of the lens, that is ADB. For the ADB, the light is behaves to travel from denser to rarer. If the light is behave to travel from denser to rarer means, okay, light is deviate from its path and move away from the normal. That's why again for this point we draw a normal. Means, sorry. It is showing this is the tangential line. The tangential line which is passing through the position of the object, this is represented the refracting surface at this point. For this one, we draw the normal. This is the normal. That's why if the light is travel from denser to rarer, it is not bent towards the normal. It is moved away from the normal. That's why like this. It is the normal. Move away. Okay, like this. Same phenomena we are observing. That's why. Okay. So then, what will happen here after the two refractions? Finally, so the first incident ray and second incident ray will become outside and they will be meet in this point. That's why it is called convergent. Convergent means after the reflection or refraction, the rays are meet. Okay, that is called convergent. That's why when the light is passing through the convex lenses, after the refraction, what will happen? The light rays are meet after the refraction. That's why it means here our light rays are converge or coincide. That's what this is called. So convex lens is as a converging lens. So for this one, what type of diagram you can draw? Simply, this is for understanding of it. It is the optic center. Oh. So that's why convex lens is acts as a means after the refraction, the rays are really meet in other side. Next one, concave lens acts as divergent lens. Divergent lens means after the refraction, the rays are never meet at any point, but appears to meet at another point. That is the meaning of that. So now here is also we can set the equi-concave lens. It is the principal axis. It is the optic center O. Okay. Here is also it will be have how many concave lens, concave, how many spherical surfaces. It is the first concave spherical surface. It is the second concave spherical surface. Here it is the rarer medium. It is the denser medium. Again it is also a rarer medium. Now the light rays are coming from the distant position of the object. We know that this is a which one? Principal axis. Like this. So when the rays are fall onto the first refracting surface of the concave lens, for this one we draw a tangential line. It is the normal. That's why after the refraction, the light ray is bent towards the normal, like this. Okay, here is also we draw like this, normal, bent towards the normal. Again, it will be fall onto the second refracting surface. Okay, for this one we draw a tangential line. For this one, it is the normal. We know that when the light is travel from denser to rarer, it will be deviate from its path and move away from the normal. That's why it is not bent like this one. It will move like again, like this. Here is also. That's why here you are observing that after the two refractions by the two concave surfaces, after the refraction, the two rays are never meet because of it is in one direction, it is in another direction. They never meet after the refraction. But the first refracted ray will produce to backward, and second refracted ray is also produced to backward. These two rays are appears to meet at another point. Okay, so at this point, image will be formed. That is later we will discuss that. So here you are observing that in case of concave lens, after the refraction, the two rays are really not meet at any point, but they are appears to at one point. From this point, we are observing these two rays. From this point, the two rays are divergent. Previously, the two rays are meet. Meet is nothing but convergent. Here, from this point, you are observing the refracted rays. From this point, two rays are moved. This is called divergent. From the point, the rays are moved like this one. That is called divergent. Okay, and all the rays are meet. That is called convergent. That's why in case of electrical bulb, when the bulb is emitted, the light rays are from the filament of the bulb. The light rays will be travel in all directions. That is called divergent light. That's why from the one point, the light rays are appears to move into the different direction. That is called divergent. Okay, after the refraction, the rays are meet at that point. That's why that is called convergent. So convex lens we are called as a converging lens because after the refraction, the light rays are really meet at one point. But in case of concave lens, it is acts as a divergent lens because the rays are never meet, but they appears to meet at another point, or from other point it is appears to the rays are divergent. So in the next class I will explain next video. So the concave and convex lens, how many curved surfaces are there? Sorry, two surfaces are there. In this one, how many focus length is there? How many center of curvatures are there? And what is the ray diagrams of the formation of image? That is discussed in the next class.